Rivers. First, you have a watershed. Watershed is all the land that drains into a river, either directly or to one of its tributaries. In this particular image, we have two watersheds. The one on the left goes all the water from this area to the left of this dotted line, flows ultimately to this part of the stream. And on the right, everything to the right of this dotted line ends up here. Every drop of water that falls into the watershed, or pollution, goes into that river. So all the fertilizer you put on your house over here, the grounds of your house over here, will flow into this river. Continental divide is an example of what that dotted line is. Continental divide is in the west, elevation 7,988 feet, and it is this line right here down the Rocky Mountains. Everything to the east of it flows into the Atlantic Ocean, ultimately, either into the Great Lakes, St. Lawrence River this way, or Mississippi River down to the Gulf of Mexico, and the Gulf of Mexico into the Atlantic, or on this side, directly into the Atlantic. Everything to the west flows to the Pacific. And this continental divide is what makes the difference between the two. A river system starts with a source, typically high grounds up in the mountains, and then flows through a river valley. Tributaries are the smaller rivers flowing into a larger river. Floodplain is the area that floods whenever the river does, and it's usually the entire area that has ultimately been carved by the river. Meanders are the curve in the river. Here is an oxbow lake, and at the bottom we have a delta, the mouth of the river. The source can either be a spring, freshwater spring, where it's flowing as the aquifer reaches the surface, or it can be precipitation, typically up in the mountains. The first stage of river development looks like this. Young stream, very steep slopes. It's a V-shaped valley, fairly straight channel, which means it's fast moving, high velocity, and its main job is eroding. Fast flowing, lots of rapids. This is your typical mountain stream. The next stage, everything's starting to look a little softer. It's been eroded a bit. The stream is meandering back and forth. It's middle-aged. The slope is a lot more gentle because it's carried down, it's washed away and eroded most of the steep mountains. And its general job is eroding sideways. The final stage of a mature stream is very wide meanders, and you can see this whole area is what that river has actually dug out for itself. A river's job is flattening the whole world. And since it is so meandering, it tends to go very slowly. The Mississippi River is an excellent example of a meandering, mature stream. Now, the main aspect of a stream that causes the erosion is stream abrasion. As water flows across these rocks, it rounds them, smooths them, and its constant flowing is constantly eroding the ground. We get V-shaped valleys. You can see this very distinct V-shaped valley, and we've got a fairly straight stream here, which indicates that this is a fairly young stream, geologically speaking. There are three things that largely determine stream velocity, or speed. Gradient. Slope is one. Steeper slope, greater velocity. You guys know that already. Discharge, which is how much water is in the stream. If there's more flow, there's also greater velocity. So floods, for example, tend to move a whole lot more quickly than the typical stream would. And the shape of the channel also makes a big difference. Deeper and wider streams move much faster because they have reduced friction. That's what you see in this. If we've got a very wide but shallow stream, it's got friction all along here, which slows it down. If you've got it very deep but narrow, Again, a great deal of friction all along here, so it keeps it slow. But if it's deeper and wider, in the center here it has the freedom, the lack of friction to go very, very quickly. Shape also matters in straightness versus curve. Straight streams, it goes faster in the center. Curved streams, it goes faster on the outside of the curve. And the maximum speed is always in the center just below the surface. Faster streams carry larger particles. And that's what we see here. Again, it's very much like a water slide. If you're coming down, you go faster in the middle, and then you hit the curve, and you swing to the outside of the curve. Greater erosion and faster speed, which is what causes the greater erosion. And deposition towards the inside where the water is moving very slowly. And then again, on the outside of the curve, faster velocity, which means more erosion.